Okay, everyone, we're going to start with some guidelines. Make sure that you have your ebook open in a separate tab, and you should be looking at the problem and not just, I will put it on the screen briefly, but maybe try it without looking at the video, or take a minute and say, do I know how to do this? And just use the video to check your answer. But don't just blindly copy me doing a math problem. This is supposed to help you master the concept. Also, listen to the video. Listening to the video makes a difference. Don't just fast forward and write down some things to get some points. Take some time. Use it as use it for the intended purpose, which is to help you practice. Also, draw all diagrams. Show all your work. Anything that I have on my paper, you should have on your paper also. Okay, I know this is a little bit grainy. I might turn the lamp on at some point, but sometimes that creates a little bit of a glare. Okay, so for 1-5, it says to graph line MU. This is pretty bad. Okay, there we go. Graph MU for M -1, 1 and U 4, 5. And we're going to calculate the slope of MU. This is a line. It's hard to see here, but there's arrows on both sides of the little line above MU. And we're going to write an equation for that line. Okay, so we're looking at the point -1, +1. And I'm kind of thinking about where's -1, +1 as I'm graphing this and figuring out how to fit it on my graph paper. -1, 1, okay. And then we've got the point 4, 5. So let's see. Okay, that's where that glare comes in. So let's try this. All right, now we're going to find the slope of this line. So my slope is my rise over my run. So I'm going to draw a slope triangle and see if I can get this light over here. A little bit better, maybe. It'll adjust. Okay, that might be a little bit better. That's not too bad. Okay, so my rise is, I don't like that shadow. Okay, my rise is 1, 2, 3, 4. You might have said change in Y last year for the rise. Okay, and my run is, usually I don't have to deal with this glare because I usually don't wait this late to make a video. My run is my change in X. Okay, so what did we say? This is 4. And my run is 1, 2, 3, 4, 5. Could you have used the formula? Absolutely. So my slope is my rise and my change in Y over my change in X. So that's going to be +4 over 5. Because remember, you always read the slope of a line. You look at the line from left to right, as if someone is walking left to right. Then that person's going to be walking uphill. So then this line is going to have a positive slope. The equation of this line, if we were using slope-intercept form, y equals mx plus b, I would put 4/5 in the place of my slope. And then I would figure out my y-intercept, which there's a few ways I can do that. I'm going to figure out my y-intercept knowing that the x-coordinate for that y-intercept is 0. So I know wherever this hits the y-axis, x is going to be 0, and I'm going to solve for y. Okay, so let's go ahead and substitute 0 in the place of x. So right now we've got y equals 4/5 x plus b, and we're trying to figure out what this y-intercept is. It's going to be a decimal. So I'm going to take one of these points, maybe since these are both positive, 4, 5, and plug in 4 for x and 5 for y. So I'm going to put a 5 where y is. I'm going to bring down 4/5. I'm going to put a 4 where x is, plus b, and now I have an equation with one unknown. That means there's one solution. Okay, so that's going to give me 16/5 plus b equals 5. Now you may say, oh, I don't want to deal with that fraction. Okay, that's fine. You're just going to subtract 16/5 from each side. And you could do that on Desmos. You could type in 5 minus 16 over 5. This isn't Desmos, but it'll give you a sense of what it would look like on Desmos. You could just type in 5 minus, now you would have to put 16 over 5 in parentheses. Okay, so I got 1.8. We could change that to a fraction, or we could just leave it as a decimal. Okay. Okay, so then the equation of this line, we're going to put 1.8 in the place of b. So the equation of our line would be y equals, we could write 4/5 as a decimal. 4/5 0.8 x plus 1.8, since we're writing our y-intercept as a decimal. Okay, hopefully that's coming back to you. It may have been a little while. For 1-7, we're going to solve, oh wait, we're not finished 1-5. Calculate the distance from M to U. Well, the distance from M to U, we cannot, every time we do this, I always have someone say, well, miss, let's just count like this. Well, you cannot count diagonally, but you can count vertically and you can count horizontally. So we know this is 4, we know this is 5, and isn't this a right triangle? And isn't the relationship between the two sides of a right triangle and the hypotenuse of a right triangle, isn't it a squared plus b squared equals c squared? C is my hypotenuse. I'm trying to get rid of that glare. So if this is the hypotenuse, and these are the two legs, we could just substitute 4 in the place of A, 5 in the place of B, and solve for C. And you can't see any of that, can you? Okay, let's try this. Oh, that's not too bad. Okay, so that gives me 16 plus 25 equals C squared, which would give me 41 equals C squared. So then I'm going to undo the squaring by taking the square root. So a lot of students will just kind of copy this all together in one step. This is one step, adding those together. The next step is taking the square root. Those are separate steps. So then C is the square root of 41. Now I know you may want to put that in the calculator and get a decimal. I'm okay with you leaving it like that. I guess we could go ahead and see what that is. Square root of 41, what's that? Okay, it's about 6.4. I guess we can put that in there. So the distance from M to U, and then in part C it says Are there any similarities to the calculations you used in parts A and B? Any differences? So the major thing to notice is that your slope, let's write this here. So this was part B. Okay, I'm going to be able to tell which one is part A and part B on your paper. Oh, the lighting is driving me crazy. Part C, the slope is a ratio. The distance is a length. So that's an important question because we're looking at a line. This is the equation of that line, y equals 0.8x plus 1.8. If I'm going to graph that on a sheet of graph paper, I need the slope, I need the y-intercept. But if I just need the distance between these 2 points, I'm using Pythagorean theorem. Okay, moving on to 1-7. We have several proportions, and we're going to solve them. So I know a lot of you, I'm going to have to turn this lamp on. Okay, for 1-7, part A, we have x over 8 equals 3 over 4. I know a lot of you will say, oh, just cross multiply and divide. You can do that. What I'm noticing is that if I divide 8 by 2, I get 4. So I know whatever this is, if I divide it by 2, I'm going to get 3. So you can probably figure out in your head, 4 times 2 is 8. 3 times 2, there you go. Didn't have to do anything there. Just figure it out. Now, they're not all going to be that simple. 2/5 equals x over 40. Well, this one's not too bad. 5 times what is 40? 5 times 8 is 40. 2 times 8 is 16. So x equals 16. If these two fractions are equal to each other, then whatever I do to 5 to get 40, I'm going to do the same thing to 2 to get this answer. Okay, part C, we have 1 over 8 equals x over 12. Okay, so this one, I can't just say to myself, 8 times what is 12? So here, I'm going to go ahead and the cross products, these are called cross products. Those are always equal. So I know whatever 8 times x is, it's going to be the same as whatever 1 times 12 is. So that's why you cross multiply. And then you've got an equation with one variable missing. It says cross products. So you're going to divide both sides by 8 to get x by itself. So x is 12 over 8, which reduces to, those are both divisible by 4. 12 divided by 4 is 3, and 8 divided by 4 is 2. So then my final answer is 3 over 2, or 1.5. And then my last one, x over 10, 12 over 15. Another one where I know these cross products are going to be equal. I can't just do a quick, easy 10 times what is 15. So I know this product, 120, is going to be the same as this product, 15 times something. So divide both sides by 15, and you get 8. All right. For, oh, I don't know why I used graph paper for that. For 1-8, let's go ahead and draw this diagram. Angela has a rectangular piece of paper, and she cuts a rectangle out of a corner as shown at right. What are the area and perimeter of the resulting shape? So let's draw this by sketching a, just do a rectangle on your paper. And I'm just using plain notebook paper here, but graph paper might actually come in handy, although you're going to be probably tempted to make it fit the dimensions of the problem, and that can be a little bit, that can take up a lot of space. Okay, so if you're doing it just on notebook paper, you're going to cut out this rectangle right here. And we know this is 6 centimeters, this is 16 centimeters, 21 centimeters, and 9 centimeters. So to get the area of a rectangle is the length times the width. So there's several approaches that we could take here. What I'm going to do is I'm going to get the area of the large rectangle. I'm going to call that a capital R, area of the large rectangle, and I'm just going to subtract this little piece right here because I don't want that. So if I can get the area of this rectangle, I can just subtract it from the big rectangle and I'll have the area of the shape that we have. Okay, so let's do minus area of the little rectangle with a lowercase r. So the area of the big rectangle would be the length times the width. Area of a rectangle is length times width, or you may have learned it base times height. So the length is 21, height 16, doesn't matter which one you call the length or which one you call the width. Now this one's a little bit harder because we don't have the length and width, but we can figure that out. If this entire side is 21, then I know from here to here is 21. So if this is 6, you can say to yourself, what plus 6 equals 21? Or you could just do 21 minus 6. So I know this length right here must be 15. You don't have to draw all these arrows. I'm just doing that to help you see it. Okay, and then we know this length from top to bottom is 16. Well, if this is 9, 9 plus what equals 16? 7. 7 and 9 is 16. So you're using the opposite side to figure out what that missing piece is. Okay, so now the area of this rectangle is 15 times 7, base times height, length times width. And I'm just going to use my calculator real quick and figure out what that is. So we have 21 times 16 minus 15 times 7. Whoopsie. 231 is what I got. Just checking to make sure I got it right. Okay. And that was centimeters, so area is written in square units, so square centimeters. And then the perimeter, you may be thinking, why are we doing this? This actually relates to something we will be spending a lot of time on this year. So you want to know the area of a rectangle and how to get the perimeter of any shape, but especially a rectangle. So the perimeter is the sum of all the sides. So we're going to add 21 plus 16 plus 6. Remember, we're looking at this shape here. So we're not looking at the entire rectangle. We're just looking at the big rectangle minus that part that's in pink or purple. Plus, okay, so I need this length right here. We figured out that was 7. I need this length right here. That's 15. I need this length, which is 9, and I think that's everything. 21, 16, 6, 7, 15, and 9. Okay, so let's just add these up real quick. Let's see, that's going to be 37, that's going to be 13, that's going to be 24, 37 and 13, that's 50. And then 50 plus 24 is 74. And that's perimeter. Oops. That's perimeter, so that's just centimeters. Okay, next we're going to do 1-16, which does have a diagram, and I do want you to draw this diagram in your notebook. Okay, it says to read the math notes in this lesson. These notes I'm going to ask you to read before you do this problem. Pause the video and read them. You might have had this in middle school, you may not have. A lot of students, come to high school without much geometry. And the book is going to expect you to know this as we move along. So read through these. I could read them to you right now, but I think it's going to be fine if you read them on your own. These are important definitions, and we can always come back and look at them. But I am going to read this part right here. An angle is formed by two rays joined at their endpoints. The measure of an angle represents the number of degrees of rotation from one ray to the other about their common endpoint, known as the vertex. In the diagram above, there are several angles with vertex G. When this happens, the angle is 3 letters, and the vertex must be the second letter in the name. Okay, so let's pause for a second. Vertex, so for example, the point where 2 line segments meet to make a corner. By the way, the plural for vertex is vertices. If I was looking at this angle right here, I could say angle C. There wouldn't be any confusion about which angle I'm talking about. That would be true for any of these angles. If I said B, there's no other angle that shares a vertex of B or A. But if I say angle G, there's actually 3 angles that have a vertex of G. Okay, the angle that is 10 degrees, this angle right here that's highlighted, you'd have to say 3 letters. You could say angle HGI. That would be one way to name it, and you put this little angle symbol in front, or angle IGH. But if you say just angle G, that is not enough for this picture. Okay, so let's look at this diagram and quickly sketch that on your paper. Don't worry about that being perfect. I would like you to have a ruler and pencils and a graph paper notebook. But if you don't have all of that right this moment, just try to get that. Let me know if you need something, and I'll try and get it to you. Okay, so we've got this diagram, and the question says, which angle below is another name for angle ABC? Well, angle ABC angle A, B, C is this angle right here. So I could name that instead of angle ABC, I could go in this direction. I could say angle CBA. So for 1-16, you could say angle CBA, but if you look at these choices, I don't see CBA. Okay, so let's see what they have here. Angle ABE. Is that going to be another name, ABE, for this angle in pink? No, ABE is this angle right here, and I am drawing this to try to make a circle for a reason. When I see intersecting lines, I see a circle, and that is going to come into play later. Okay, so not ABE. The next choice is GBD. And let's look at that. GBD, and B is right here. So GBD. FBD would be this angle. This is not really looking like a circle. There we go. GBD is this angle right here. Well, that's not the same as ABC. And then we have FBG. FBG. Oh, that would work. FBG is another name for angle ABC. So you've got some extra letters on this ray, so that makes it a possibility. And then EBC, let's look and see where EBC is. EBC, okay, that's going to be 180 degrees. So that's this entire half of the circle, so that's not going to match the pink part. Okay, so that takes care of 116. 117. If no sides of a triangle have the same length, the triangle is called scalene. And as you might remember, the triangle has at least two sides that are the same length. If it has two sides that are the same length, it's called isosceles. So use the markings or description in each diagram to decide if ABC is isosceles or scalene, and assume that they are not drawn to scale. So we are going to sketch these in the notebook. Okay, for part A, we have markings here and here. So that is saying that these two sides are equal. Well, if two sides are equal, if a triangle has at least two sides that are the same length, it's isosceles. So this would be an isosceles triangle. B, and remember it said it's not drawn to scale, so it almost looks like this is the same triangle, but what that means is when they say it's not drawn to scale, you can't just measure these sides and say, oh, this is the same as this is the same as this. In the book, on a test, you can't do that. You just have to go by these markings, and these markings are saying that all three sides are different lengths. So then this would be a scalene triangle. Okay, and then part C, we have a square with a diagonal. Well, if this is a square, and I'm not making an assumption that it's a square, which we don't make assumptions when it comes to geometry. If this is a square, all four sides must be the same. So we have an isosceles triangle here, and we have isosceles triangle here. So we have two isosceles triangles. Okay, part 118 says finding and using a pattern is an important problem-solving skill necessary for your study of mathematics. The patterns and diamond problems are used later in the course to solve other types of algebraic problems. So we're going to look for a pattern in the first three diamonds below. For the fourth diamond, explain how to find the missing numbers if you know the two given numbers. Okay, so let's look at this diamond here. We have a 5 and a 2 and a 10 and a 7. You may see it already. Here we have a 2, a 3, 6, and 5. -1, -4, 4, and -5. So what are we doing with these two numbers to get that number on the top? Do you see it? Pause the video if you don't. And take a second. Isn't 5 times 2, 10? Isn't 2 times 3, 6? Isn't -1 times -4 +4? So you are finding the product of those two numbers. That's what's going on top. And then let's look at the number on the bottom. Isn't 5 plus 2, 7? Isn't 2 plus 3, 5? Isn't -1 plus -4, -5? So then the number on the bottom is the sum. Okay, so let's make a note of this. You're going to be using this a lot this year. So we start off with some simple numbers. And it takes a little while to figure out how to draw that diamond. It's okay, you'll get better at it as time goes by. So I'm going to let's put an X and a Y here instead of just the number sign. Okay, so this is going to be X times Y. This is your, product. And then this is going to be X plus Y. This is your sum. So let's just use that. I'm going to draw, you might want to, I'm going to pause this. So maybe pause the video, draw the 5 diamonds that we have. Also, I just realized I flipped over to this lesson and I forgot to tell you this, I'm in lesson 112. So we're doing a couple problems from 111 and a few problems from 112. And by the way, this is the last one. Also, I realized I should kind of show you how to do this. I do these two sides, and then I do these two sides to make the diamond, and then I do this in the middle. So I know some students have a hard time drawing those. Don't stress. You could also just do the X and then do the sides. That one didn't come out too good. Okay, we've got a 3 and a 5. So I know I'm going to multiply to get the top, and I'm going to add to get the bottom. Part B, we've got -2 and -1. The product is 2. The sum, -2 plus -1, is -3. Use those words. Think about those words. C, we have the answer for C. So we have we're looking for two numbers that give us a product of 8 and a sum of 6. What can I multiply to get 8? But when I add it, I get 6. Is 2 times 4 going to give me 8? And is 2 plus 4 going to give me 6? There you go. It's kind of like a fun little puzzle. Okay, part D, we've got 8 and 1/2. So I'm going to do 8 times 1/2. 8 times 1/2 is 8 halves. 4, 8 divided by 2. 8 plus 1/2 is 8 1/2, which, let's write that as an improper fraction. 2 times 8, 16 plus 1, so 17 over 2. I guess you could just write 8 1/2. And then for part E, what could we multiply to get 12? When we add it, we get -7. So think about what you can multiply to get 12. 2 and 6, that's going to give you 12. When you multiply, is it going to give you -7 when you add? No. How about 4 and 3? That's going to multiply and give me 12. Is it going to give me -7 when I add them? No, that would be +7. So what do I need to change so that it adds up to -7? Well, if I make both of these negative, that still gives me a +12 when I multiply. Still gives me, and it gives me a -7 when I add them. Okay, good job, everyone. Make sure you refer to that document about how to upload your assignment in School